Hello friends, welcome to engineering tutorial. Um in this video we are going to discuss the second question related to signal flow graphs and determination of the transfer function using Mason's gain formula. Okay, so here again we have been given a signal flow graph and we have to determine the transfer function Cs by Rs. Cs is the Laplace transform of the output, Rs is the Laplace transform of the input node and output node, and we have to determine the transfer function of the system using Mason's gain formula. So first we have to determine the number of forward paths, then the number of loops, the path factor of the individual forward paths, and then the touching and non-touching loops. Okay, and then put the respective values into Mason's gain formula. So the Mason's gain formula, it states that the transfer function Cs by Rs is given by P1 delta 1 plus P2 delta 2 Pk delta k. These are P1, P2, Pk are the forward paths, the gains of the forward paths. Delta 1, delta 2, delta k are the path factors of the respective forward paths, and then we have the graph determinant. So we have to find out the respective values and then put it in this equation. Okay, so first let us determine the forward paths. Okay, so definition of forward path, we know it is a number of branches, a group of branches joining the input node and the output node in one direction with no nodes repeated. Okay, so let us see. There is one obvious forward path, this one R1 2 3 C, R to 1 to 2 to 3 to C. Always pay attention to the direction of the arrowhead. It is in one direction, R to 1 to 2 to 3 to C. Okay, so that is forward path number 1, R to 1 to 2 to 3 to C. The gain is the product of the individual branch gains, G1 into G2 into G3 into G4, G1 into G2 into G3 into G4. Okay, let us see if there is any other forward path. Yes, see, R to 1, okay, R to 1, then this 1 to 3, see the direction of the arrow, R to 1, 1 to 3, 3 to C. Okay, it's fulfilling the definition of the forward path, joining the input and output node in one direction in the forward direction. Okay, see, R to 1 to 3 to C, that is path number 2, R to 1 to 3 to C. So the gain is G1 into G6 into G4. Okay, G1 into G6 into G4. Okay, let us see if there is any other forward path. Yes, again R to 1 directly to the output node C, R to 1 to C. Pay attention to the direction of the arrowhead, R to 1 in the forward direction, again 1 to C in the forward direction. So P3, the third forward path, is R to 1 to C. The gain is G1 into G7. Okay, let us see if there is any other forward path. Is there? No, I don't think so. If there is any other forward path, no, there is no more forward paths. Okay, so there is only these three forward paths. Okay, now let us determine the loops. Okay, so always while determining a loop, pay attention to the nodes. I've already told, I've used it in the previous question. If a node has outgoing and incoming arrows, okay, that means outgoing and incoming branches, it means it has a loop associated with it. See this node, node number 1, it has an outgoing arrow and an incoming arrow, so this is a loop. See, 1 to 2 to 1. The basic definition of a loop says that it is a closed path formed by branches which start and end at the same node. Okay, it is a closed path formed by branches which starts and ends at the same node. So here it is, loop number 1, 1 to 2 to 1, 1 to 2 to 1. The gain of the loop is the product of the individual branch gains, that is G2 into H1, G2 into H1. Another loop, yes, look at node number 3. See, it is a closed path involving only one branch. See this, it starts at node 3 and also ends at node 3. So loop 2, see, 3 to 3 only, loop 2, 3 and 3, it starts and ends at 3, the gain is only G5. Okay, any other loops? No, there is no other loop. Okay, so it has 3 paths and 2 loops. Now let us determine the path factor. We have to determine 3 path factors for P1, P2 and P3. Okay, and then we have to determine the touching and non-touching loops. Okay, let us first determine the touching and non-touching loops, as there are only 2 loops. See, 2 loops are said to be non-touching. The definition says the 2 loops are said to be non-touching if they have no common nodes in between them, and if they have common nodes, it means they are touching to each other. So the nodal representation of L1 is 1 2 1 and that of L2 is 3 3. So there is no common node in between L1 and L2. See, L1 1 2 1, L2 3 3, no common nodes. It means N1 and L2 are 2 non-touching loops. N1 and L2 are 2 non-touching loops. 2 non-touching loops. Okay, next we have to determine the path factors. Now for path factors, we have to compare the nodal representation of each path with each of the loops. It is similar to the touching and non-touching loops determination. If there will be common nodes between the nodal representation of the paths and the loops, it means the path is touching that loop, and if there is no common node between the path and the loop, it means the path is not touching that loop. Let us first compare P1 with L1 and L2. P1 is R1 2 3 C, L1 is 1 2 1, 1 2 1 2. So it is common node between P1 and L1, so P1 is touching L1. Next with L2, R1 2 3 C, here it is 3 3. So 3 and 3 common nodes. So P1 is touching L2. So P1 is touching both L1 and L2. So path factor is 1 minus sum of the loop gains of the loops which the path has not touched. Okay, the definition of path 1, expression for the path factor is 1 minus sum of the loop gains of the loops which the path has not touched. As it is touching both the loops, so it is 1 minus 0 is equal to 1. Similarly, we have to compare the nodal representation of P2 with L1 and L2. So P2 is R1 3 C, L1 is 1 2 1. So 1 1, there is common node between P2 and L1. So P2 is touching L1. Now we have to compare P2 with L2. R1 3 C, here it is 3 and 3. So 3 and 3. 3 here and 3 there. So there is common node between P2 and L2. So P2 is touching L2. So it is touching both the loops. P2 is touching both L1 and L2. So here also it is delta 2 is equal to 1 minus 0 equal to 1, as it is touching all the loops. Next, we have to compare P3 with L1 and L2. here it is R1C, here it is 1 2 1 1 1 common node, so P3 is touching L1. Here it is R1C, here L2 has 3 3, no common nodes, see, no common nodes, so P3 is not touching L2. So the path factor for P3 is 1 minus sum of the loop gains of the loop which the path has not touched. As it is not touching L2, P3 is not touching L2, so we have to include that loop gain here, G5. Okay, so we have determined delta 1, delta 2, delta 3. We have determined the forward paths, the loop gains and the non-touching loops. Now all we have to do is apply these things in the equation and we'll get the transfer function. Okay, so before putting the Mason's gain formula, first let us determine the graph determinant. It will be easy to put. So graph determinant we know is 1 minus sum of the individual loop gains, okay, the sum of the individual loop gains plus sum of gain products of two non-touching loops. Okay, two non-touching loops, gain products. So let us do that. So there are only two loops, L1 and L2, and they are not touching with each other. So the gain products of the two non-touching loops is the product of the two loops, that is G2H1 into G5. L1 is G2H1 into L2 is G5, so it will be G2 G5 H1. Okay, now we have to put it in delta. Delta is 1 minus sum of the individual loop gains. L1 is G2 H1 plus L2, which is G5, plus L1 L2, sum of gain products of two non-touching loops, that is G2 G5 H1. So this is the graph determinant. Now let us put it in the Mason's gain formula to determine the transfer function. So now we have to just put the respective values in Mason's gain formula. So the Mason's gain formula, the transfer function of a system is given by, there are three forward paths. It will be P1 delta 1 plus P2 delta 2 plus P3 delta 3 by delta, which is 1 minus sum of the individual loop gains plus sum of gain products of two non-touching loops. Okay, so let us just put the respective values together. P1 delta 1, delta 1 is 1 and delta 2 is 1, only delta 3 is 1 minus G5. Okay, so it is G1 G2 G3 G4 into 1 plus, it is P1 into delta 1, G1 G6 G4, just P2 into delta 2, which is also 1 we calculated. Then is P3, forward path gain number 3, which is G1 into G7, and delta 3 is 1 minus G5, this G5. So this numerator part is over. Next, the graph determinant, it is 1 minus sum of the individual loop gains, as there are only two loops, that is G2 H1 plus G5, and there is only one two non-touching loop, pair of loops that do not touch each other, that is L1 L2, and the gain of L1 L2 combined is G2 G5 H1 plus sum of gain products of two non-touching loops, which is G2 G5 H1. Okay, so this is the transfer function of this signal flow graph that we have here. Okay, so this is how you calculate. So I hope you liked this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.